numbers on a paper.
Hello dear friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at this complex integral we have on screen guys. Though I said it's a complex integral guys, but I'm going to make it a super easy integral for you today. So guys, before we get started, let's introduce ourselves. I am Omenjo Macarius guys, my Christian name is Macarius. In Humble Mark Academy guys, I take complex science problems, the ones that are very difficult for students to understand, complex science concepts, the ones that are so difficult for all my students to understand guys. I break them down into tiny pieces such that any student in any part of the world can use it, and in any level of education can use those concepts now to score a better mark in his or her exam. In exchange guys, all you need to do now is to please subscribe to the channel. That is your own gift to me. It does motivate me to keep producing more great content guys. It gives you the motivation and the courage to keep this channel going. And friends, please give the video a thumbs up, and friends, press the notification icon to get notified so that each time I upload the video, you're going to be the first person to get notified. Great. All right guys, let's look at this integral. So friends, I noticed that this is an integral going from negative infinity to positive infinity guys. My major concern here are the fact that the limits of integrations are symmetrical, namely from a negative limit to the positive of that same value. Great. And friends, since I have a fraction, I have the top, which is an even function. You can verify that, friends. Then I have 1 that's greater plus 10 raised to the power sine of x. Keep in mind that sine x is an odd function. So guys, in such a case, my integral can simply just die down to the integral from 0 to infinity of just the even part, that is e raised to the power negative x squared dx. And as you all know guys, this is one of the famous integrals we know in calculus to write, namely the Gaussian integral. So in this case guys, since this is just half of it, because it is just like the half of the Gaussian integral, and the value for this our improper integral guys is simply going to be what, the square root of pi. But since it is half of it guys, it's going to be the square root of pi over 2. Great. So guys, why is this so? Okay, why does such integral die down to just this y? All right, let's look at the proof guys. Let's suppose that we have an integral going from negative a to a of h of x over 1 plus k times 1 plus k, where k is a constant, raised to the power f of x squared dx. So guys, this integral is just going to die down to the definite integral going from 0 to a of just h of x dx. So guys, under what conditions is this possible? Under what condition is such a situation possible? This is possible only when we have our h of x to be the same like h of negative x. Namely guys, our h of x is an even function. And guys, condition number 2, this is true when our f of x is equal to what? F of negative is the same like negative. That's when our f of negative x is the same like negative f of x. In other words guys, f of x has to be an odd function. Great. All right guys, so these are the two conditions under which this is possible. For instance guys, what if our f of x here was, what if here we had a cosine function? This condition fails. Okay, it fails. So guys, such equation like this is so frequent in the exam, and so many students always leave it unanswered, not knowing that it is actually very easy guys. So after watching this video guys, you shall be able to grab those marks, while other students will be scared away from it. All right, so guys, let's look at the proof of this. Let's look at the proof. Let's prove this result. Okay, and let's prove that if you have an integral like this, it simply dies down to just integral. All right, let's have the proof here. So guys, this is the integral that we have. Integral going from negative a to a of h of x over 1 plus k raised to the power f of x. So guys, we can split the integral into two parts since we are from 0 to a, so we have to split it somehow. So we are going to have now the integral going from negative a, we stop at 0 of the function, plus we continue from 0 and we end at a of that same function. Great. All right friends, let's look at the integral in blue. Let's look at the integral in blue here. Okay, because our aim is to make the limits of this integral the same as this guy, since here we only have from 0 to a, we don't have a negative a somewhere. Great. So in this case guys, to achieve this, we are going to do some substitution. We are going to let our x to be negative u. That therefore implies guys, if we differentiate x, we are going to have negative du. All right, so our integral now guys simply translate into, keep in mind that this negative a and 0 are x values. So when x becomes negative a, you plug in it here, our u becomes what? A, right? And when x becomes 0, u obviously becomes 0. And keep in mind that dx is what? Negative of du. That's the point in place. We're going to have negative of the integral from a to 0 of h of our x is negative u, and our x as well is negative u. Great. So we're going to have 1 plus k raised to the power f of u du. But friends, what condition did we give for h of x? H of x has to be what? Equal to what? H of negative x, or better still, h of negative x has to be the same like what? H of x. Namely, h of x is an even function. So, and what condition did we also give for f of x, right? That f of x, f of negative x has to be the same like what, guys? Negative f of x. So this our integral again dies down into just the integral. And guys, keep in mind that negative of the integral from a to 0 simply means what? Positive of this integral now from 0 to a. These are some of our properties of definite integrals. So we are going to have from 0 to a, then h of x is an even function, so we're going to have h of u plus 1 plus k. Since f of x is an odd function, here we're going to have what? Negative f of u. So friends, one thing I want you to take note is that u and x are dummy variables in this case, okay? So we can simply replace their values conveniently where we are to do so, okay? They are both dummy variables, so you don't have to bother yourself. All right, so in this case, friends, if you multiply top and bottom by k raised to the power f of x, we are therefore just going to have h of u into k raised to the power f of u over 1 plus k raised to the power negative f of u. We multiply with k raised to the power f of u. Great. By so doing, guys, f of k raised to the power f of u multiplies here. We're going to have k raised to the power f of u. It multiplies here, guys, since they are both inverses. It gives us simply 1. So we are therefore going to have the integral going from 0 to a of h of u k raised to the power f of u over k f of u k raised to the power f of u plus 1. All right, guys, like I said, guys, x and u are dummy variables, so we can replace their values conveniently. So where I'm going to replace all the u's with x, and I'm going to add this my black integral here that we left initially. Keep in mind that all along we have been working with the integral in blue, but the entire integral comprises of what this, so we are going to add it. So we are therefore going to have now the integral going from 0 to a of h of x k raised to the power f of u, which is this one, f of x. Since we have replaced all the u's with x, so we have it like this of this form plus this our black integral. So in this case, guys, if we now put everything inside of one integral, we are going to have the integral of h of x k raised to the power f of x plus everything. So everything remains the same, guys. So in this case, since the denominators are the same, we can combine it, and the numerator, guys, we can factor out h of x, right? So we are going to have now the integral from 0 to a of just h of x. We are going to have k raised to the power f of x plus 1. All over what they share in common is 1 plus k raised to the power f of x. So friends, 1 plus k raised to the power f of x is upright. It can cancel with the 1 at the bottom. So we are therefore going to have just the integral going from 0 to a of h of x dx. Great. So guys, that's the proof. Okay, that's the proof. So guys, each time you look at these integrals, you should just simply recognize that you can use this fact. Okay, once these two conditions have been satisfied, and you should have 1 here. Okay, here has to be 1. Once you have 1, guys, go ahead and use it. Great. So guys, I hope you found the video so useful. If you found it useful, guys, like I said, a simple thumbs up will mean the world to me, guys. And subscribe to the channel if you're not subscribed. If you don't subscribe, guys, you're going to miss out on all latest updates we are going to be uploading in this channel. Thank you so much, guys, and have a blessed day.